Okay, in this video we are going to learn about the expected value and the standard error of x bar. And these are actually special names for the mean and the standard deviation of d of x bar. Okay, so first of all, the mean of d of x bar is called the expected value of x bar. Okay, the expected value of x bar, and it is equal to the mean of the population. Okay, and so we could write that out then. Here, let me, there we go. So we could write this out by saying mu with that little x bar subscript is equal to the mean of the population. So this is the symbol for the expected value. Okay, so the mean of the distribution of x bar is called the expected value. That's a special name for it. So here's kind of the idea. If this is the distribution of all the possible sample means, so if this is a d of x bar, right, and so all the possible sample means are distributed all around, well, you kind of expect the mean of your sample here. You would expect it to be kind of close to the mean of the population. It's kind of like if you took out just a single value from the population. That value could be anywhere, but if I took out 50 values and averaged it, it would be, you know, that would be close to the mean of the population. And so it ends up that the way that it's distributed is kind of this normal shape, and it's centered right there at the mean of the population. So when you draw out a sample mean, it's much more likely to get a mean equal to the mean of the population than to get one of these means that are further out. Okay, so the mean, what you could say is the expected value of x bar is the mean of the population. The mean of the distribution of x bar, the expected value of x bar, is the mean of the population. Give or take a little bit, though, because not all the means are going to be, you know, you could get means that are further out. Okay, so there is some sampling error, okay, depending on how far out the value is. The further out it is, the more sampling error there would be. Okay, so that sampling error, we're going to find out, is actually measured by the standard deviation of the distribution of x bar. And so they call the standard deviation of the distribution of x bar, they call that the standard error of x bar. So let's look at that next. So the standard deviation of d of x bar is called the standard error of x bar. The standard error of x bar. And then we could say it is a measure of sampling error. It is given by the following formula. Okay, so this is the symbol. It's the sigma, the standard deviation symbol for a population, with a little x bar subscript there. and it is equal to the standard deviation of the population divided by the square root of n. Okay, so both of these things influence it. So the larger the standard deviation of the population, the bigger the standard error will be. So if the population's varying all over the place, that's going to mean you're going to have more sampling error, okay, because it varies more. But the bigger your n is here, the smaller the standard error is going to be, because you're dividing by the square root of n, okay? And so the bigger the n, the less error you would expect to have. It's going to make your standard error smaller. And so this is exactly what fits our intuition. We could write this. The larger, for any given population, the larger the sample, the smaller the standard error. Which means to get less sampling error, draw out a larger sample. Okay, and that makes sense. So if you want less error, you just pull out a bigger sample. So once someone is doing a study and they really want to make sure that they get the best results possible, well, the larger the sample they take, the better. Okay, and so you could kind of look at it sort of like this. If you have, let's say, a d of x bar like this, and this is the mean, it's equal to the mean of the population. And then let's say you have another one, maybe that's more like this. I didn't do very good here. But the idea is this one would have a larger standard error. This one would have a smaller standard error. Okay, so if it's more spread out, that means your standard error is larger, and that means the sample means could be all over the place. You would be more likely to pick a sample mean that's far away from the mean of the population. Okay, you're going to have more sampling error. But if this thing is all scrunched up around the mean, then most of your sample means are going to be close to the mean of the population. You'll have less sampling error. Okay, and so this actually fits our intuition. And this value is actually something that we use in a statistical study to help us calculate how much error we should expect to see when we make a certain estimate. So if you've ever heard of someone reporting a study and they say the margin of error, or maybe a political poll with a margin of error of a certain amount, this is related to this standard error. And the standard error is actually a number used in a formula to get the margin of error. And we're going to be seeing these sorts of things when we get to chapter 7. So, okay, in the next video, we're going to learn a little more about the central limit theorem and what that is all about.